So hey nerds, this is Suman and in this video we're going to discuss about very much interesting thing about physics, that is photoelectric effect. And this is the experiment, or this is the effect on which Einstein got Nobel Prize, not for his two theory of relativity, right? So basically Einstein got Nobel Prize for this thing, I think in 1905. I'm not very precise with date, but around in 1990s. So basically, whether I have to say it was discovered by Holwach or the Henrik Hertz, so it depends on your choice, because I think it was Holwach for the first time, and later the Hertz also discovered the same phenomena, but they do not have any mathematical evidence to support their idea, because the idea is already published, but no one has actually put formulated the mathematics uh, how this effect is going to apply in the nature. So basically in 1905 Albert Einstein came up with a brilliant idea with the conservation of conservation of energy, and formulated the beautiful relation of photoelectric effect. Right. So basically the photoelectric effect is nothing but if you have a metal surface like here and metal surface like here, there will be free electrons here. So free means they are not allowed to move from the metal surface, because if they move from metal surface they ionize. So they do not ionize, but they can move here and there, and they can wiggle everywhere they are possible, but within the metal surface, not far from the metal surface, otherwise the metal surface is ionized. And when we apply a suitable frequency of light, the energy is used in two parts, that is on doing some work in this surface, and the remaining energy is taken by electron with some kinetic energy. So this is not the excitation or de-excitation phenomena. This is just the fact that we are just knock out, we're just taking out the electron from the metal surface, so they actually get out from the metal surface. So this is the fact, there is no excitation and de-excitation of electrons in this phenomena. So Einstein came up with a brilliant idea. So how we can tackle this? So basically he formulated a formula, that is hf minus hf naught is equal to 1 by 2 mv square, and this fact allows how the photoelectric effect is actually done and how the energy actually depends on frequency of light. So when you hit something and that goes out from there, you can actually predict that it might be the particle that is ejecting something. So if you had looked up the carom board, so in my country we play actually carom board, and if you had that what we say, I really striker. We say striker for that. So and when you strike that, when you shoot the striker, let us assume that would be our photon, and it is going to hit the carom, the simple carom that is going. It is going to hit that carom. So it is like the electron that is gaining kinetic energy when it was struck by the photon or the striker, right? So this is the kind thing that when a particle hit a particle, the particle will eject out or get some momentum, right? So this fact actually proved that the photoelectric effect is based on conservation of energy, and it proves the particle nature of light. So light has actually dual nature, so it behaves as wave, it behaves as particle, and this is the phenomena where the light is behaving like particle. So this is the direct consequence of the photoelectric effect, is direct consequence of the fact that the light is particle. It is of both nature, but this thing actually proves light is a stream of particles. So let us go into a very much deep intuition. Let's apply how the Einstein formula actually came out, whether it is true or not, because it is based upon my idea and my assumptions, but it makes you think in a very much different way about photoelectric effect. So what is actually going inside an atom when the electron get hit by the photon? So let us go into whiteboard and let's do the mathematics. So nerds, let's go into the very much detail of photoelectric effect. Whether it would be detailed for you or not, if you had already learned this stuff. So if you hadn't learned this stuff, you will get something very much interesting. And if you had already learned, again you will get something very much interesting, I guess so. So the fact is that we have to understand photoelectric effect. So we are not going to derive the whole bunch of equations, and we are just going to take the feel how this apply in a subatomic level. So basically it starts from a metal surface. So it is actually a metal surface and it has atoms. It is made up of atoms. So I am using the classical idea just to visualize this fact. So don't get offended here. And these are the free electrons within the nucleus, and this is the bond between, just to show that the nuclear electron is bounded with nucleus. So the fact is that that when you apply a radiation, so radiation is drawn like this. So when radiation is applied, the electron will eject out with some kinetic energy. So electron acquires some kinetic energy. So this is the thing that the Hors and the Hallwatch is actually observing in their experiment. So according to Planck's radiation law, the energy of photon is hf. So according to Planck's radiation law, the energy, so I am writing EP as energy of photon, that is equal to hf. So the energy of photon is hf, and when it hits this metal surface, the electrons are eject out. So this is not the excitation and de-excitation I had already told you. The electron acquire kinetic energy. Okay. So if you know the fact that the electron is bounded with nucleus with some negative energy, if you know this fact, so they have to overcome this some negative energy, and the photon has to do some work on this metal surface. Some work on this metal surface. I hope you realize this, because in order to break the bond, you have to do some work, and the remaining energy will convert it into kinetic energy. And we got the interesting relation, that is hf equals phi plus 1 by 2 mv square. Okay, this would be the correct equation. So basically the photoelectric equation is hf minus phi is equal to 1/2 mv square. So this is the surface thing that we all had already known from our higher classes, in our class 12 physics. I guess in my country it starts from the class 12 physics. So I would like to take you into a very much deep down. I would like to take you into a very much detailed factor, that is, let us go and okay, this is my metal surface with some positive ions, and it is neutral because of the same amount of negative ions. Okay, and let us zoom this. Now we are using an ideal scenario. Just we are zooming into a particular atom. Let us say we are zooming with this atom. So we are zooming, and what we see here is a positive ion, and it is surrounded by a negative electron. So we are just doing in a classical picture whether I had to make this thing or not, or the orbit. So let us assume that this is the probability of finding electron. Here is the electron for us. The electron is probably here for us. It makes sense. And here is our nucleus. Let us say that ZE. And we are just seeing the outermost orbit of an electron. So we don't have to use, this is not a hydrogen atom, we are just showing the outermost electron of this thing. So we don't actually require atoms, but just to see the fact that. So I would like to show you something very much interesting here. So if you are already known about this fact that the total energy of electron is negative. The negative meaning is the electron is bounded with nucleus. So it is a bound particles. So electron is bounded with nucleus. Let us assume that the electron is bounded with nucleus with some energy, E bound. So bound energy is nothing but our minus 20 joule. Let us assume that it would be our 20 joule of energy. The electron is bounded with 20 joule of energy. So it is not the negative energy, just the sign is negative. So we are just for an example because I want to show you a feel of how the photoelectric equation actually applies here. Okay. So let us draw a simple bond here just to understand. So the bond is of energy 20 joule. So now we are applying photon, energy of photon. Energy of photon is, let us assume that 50 joule. So when the 50 joule energy of photon, we are just doing an example, right? So when 50 joule energy of photon gets hit on here, what would happen to this? So I would like to say that I would like to show you some classical picture just to. So let us say this is the mass, this is a block. So this is a block and it has, let's say, some inertia is the energy factor, right? In order to understand the concept, let's say the inertia is, we have written in terms of energy. So it has some inertia, we're just replacing it with energy for our convenience in order to look up here. So let us say it has some energy, rest energy of 20 joule for an instance. Okay. So in order to move this, we have to apply energy more than this, I guess so. Whether you believe me or not. So in order to move this block with our bare hands, in order to slide this object up to here, so we must have our energy greater than or equal to 20 joule. So for the fact that photoelectric effect can cause in the 20 joule energy also, because it is the phenomena of ejecting out electron. So if you broke the bond between these two things, electron and nucleus, the photoelectric effect immediately occurs. Whether electron gains kinetic energy or not, it doesn't depend on that. If the electron and the bond between electron and nucleus, for an example of our, the bond between electron and nucleus, if it breaks, if the bond is breaks, the photoelectric effect occurs. Indeed it occurs. So let us say, I just want to take with an analogy. So electron is actually in a depth, I think depth is the right word or not. It has negative 20 joule energy. So it borrows minus 20 joule energy from someone, and you are giving him 50 joule energy. So if you give 20 joule energy, let us say that we give only 20 joule energy. So he has depth of 20 joule and you give 20 joule, the electron will be free and the electron obeys photoelectric effect. If it doesn't gain kinetic energy also. So it doesn't gain kinetic energy, but it is free. So this is also a photoelectric effect. So, right? And if you give more than 20 joule energy, again this will be free and get some additional amount of energy. Right? So it has negative 20 joule. And if someone giving it 50 joule from the external source, the 20 joule is expanded in the form to break this bond, right? And the remaining 30 joule energy is converted into kinetic energy. Isn't that very much interesting? Now the bond is break down and the electron gains kinetic energy 1/2 mv squared. So you are applying, now just we have to apply the conservation of energy thing, right? Just conservation of energy. So now we have applied 50 joule of energy, right? Just we apply 50 joule of energy and 50 joule is converted into 20 joule just to break the bonds between these two things, nucleus and electron, and the remaining 30 joule energy is converted into kinetic energy. So it is 30 joule. Isn't that very much interesting? Conservation of energy applies here. So I would like to recall this fact that you can actually see from here the energy of photon is converted into two factors, that is to overcome this energy barrier. So in order to overcome this energy barrier, and the remaining energy is converted into kinetic energy of electron. So it occurs spontaneously, not firstly the bond breaks and the electron gains kinetic. No, it immediately occurs, right? So I have to write in formula that HF minus phi is equal to 1/2 mv squared. This is my equation 1. So I had told you if we had applied just 20 joule energy, if we had just applied 20 joule energy, so let us assume this would be our electron, the outermost electron, this would be nucleus, and there is some bond. So if it bounded with negative 20 joule energy and we supply photon of energy 20 joule, the bond will break because it would be free. If you are in debt of 20 rupees and someone gives you 20 rupees, you would be what? Free. So again this bond will break. So this is the condition that the energy of photon, should be greater or equal to binding energy. Binding energy. So why have we used inequality sign? Because if the photon energy is 20 joule and the binding energy of electron is minus 20 joule, so photoelectric effect occurs because there is nothing that, because the electron is free from nucleus. This is photoelectric effect. So if you applied 50 joule, instead of giving 20 joule, you give it 50 joule. Again the bond is going to be break, or simply the electron will be get firstly free and the remaining energy is going to convert it into kinetic energy. Isn't that beautiful? So this is the condition that the energy of photon should be greater or equal to the binding energy of electron. So this binding energy hour is phi. So energy of photon is HF should be greater or equal to phi. So in most, I would like to tell you a secret. In most of the cases, the binding energy is actually equal to phi. It is also very much beautiful thing. The binding energy is just equal to the threshold energy, if you had heard this term before. So this would be equal to phi, right? And in order to just remove the inequality sign, if we replace, I would like to replace, so h is our constant. So if I change the frequency to the new terms, another thing of frequency, let us assume that the binding energy is 20 joule, negative 20 joule, and HF is our 50 joule. So what is happening here? We have 20 joule minus 20 joule as energy, threshold energy, and the photon energy is 50 joule. But now I want to make, but I know the fact that this 50 joule is going to convert it into 20 joule to break this bond, right or wrong? Right. Plus remaining is converted into kinetic energy, that is 30 joule. So I would like to replace this frequency in terms of another frequency. So I can write HF naught is my 20 joule. Isn't that beautiful? So I am writing this energy term as HF naught. So when I write this HF naught, it would be equal to phi. Right? So HF naught should be equal to phi, and I got phi is HF naught. Right? Isn't that beautiful? So what would be our final formula? So the final formula is going to be HF minus HF naught is equal to 1/2 mv squared. So this would be our final formula. So this is how the formula has came out. And this F naught is nothing but threshold frequency. Threshold frequency. Or you can simply say that the energy HF naught is divided into two parts. HF naught plus 1/2 mv square. Right. So this is the energy, this is the energy. Or you can simply say that, so you can simply say that phi is equal to HF naught. We got this formula, right? So you can actually say from the fact that from this relation, the photon, the energy of electron, the total energy of electron, the binding energy of electron indeed follows the Planck's radiation law in some sense. Because in Planck's radiation law, we have energy is HF, and in terms of we have binding energy or threshold energy, what do you want to call, we got HF naught. So isn't these two look similar? So this is for photon and this is for electron binding energy. So it seems us to like that the energy the total energy of electron also obeys the some kind of Planck's radiation law, right? So I would like to confirm you that one thing, that our actual frequency of photon should be greater than F naught. So this is the fact. Because this has 20 joule only energy, right? It has only 20 joule of energy. So it has lesser frequency. F naught will be lesser. It has 50 joule energy. So it has higher frequency. So this would be the condition. So the energy of photons should be equal to like this. Up to here, I think it makes sense to you. So I think you got something feel about how the quantum phenomena actually occurs, right? So guys, I hope up to here you have understand something new, and up to there, bye bye.